Okay, so how was your 9 stuff so far? Those go okay? You notice how 9-3 kind of ran through, or 9-2 ran through all of that stuff because you had to come up with your positive stuff in there, and getting those things to work and coming up with what you had to have with that part. 9-3 was all of the exponential stuff with fractions of anything in there that we need to go over. And then 9-4, we only did A and B, but they were working like similar to polynomials and combining like terms and getting like stuff to come together for those. So anything with those? No? Okay. Well then, let's take a look at what we can do with 9.4c. And we didn't do this one the other day because you needed some of the skills and stuff that you needed from 9 for A and B to do some stuff with 9.4c. And so therefore, and it would have really loaded too much at one point to end up doing all of that. So we figured we'd split it off and do it separately and come up with what we need to do. In rationalizing denominators, what this means is we cannot have anything that is left as a radical in any denominator that we're working with. So we have to get rid of it. And sometimes to get rid of it, you just multiply it by itself. Other times you multiply it by what you're missing to make it a perfect cube, a perfect square, if it's a binomial, to use its conjugate to get rid of it, and so forth. So in rationalizing it, it says the denominator contains a square root. Multiply both the numerator and denominator by the expression that will give the denominator with no square root. So we want to get rid of those. So we don't want any of those to be there. If the denominator contains a cube root, multiply both the numerator and denominator by an expression that will give the denominator no cubed roots. So when you have a cube root, for instance, if I had the cube root of 3, I can't just remove that because there's not 3 3's under here, okay? But if I took this and I multiplied it by the cube root of 3 squared, what would happen then is I would end up with the cube root of 3 cubed, because this 3 has a 1. 3 and the 1 and the 2 added together gives me a 3. So then I can take this and I can end up with just plain 3 when I'm all done. So in cube roots, we have to watch what the value is here and what we need to multiply it by in order to get rid of it and to remove it. So cube roots are a little different, and we'll work with those as we go through these. So here's a couple examples. If you look at this first one, I have the square root of 2. And what this tells me is I need to get rid of it. Since this is my denominator, I need to make that into a solid 2. So what would I still need? This 2 is to the first. So what I would need to multiply the denominator by is the square root of 2. But as always in algebra, whatever you do to one piece, you always do to the other piece. So I want to multiply also the top by the square root of 2. And so what happens is I have square root of 5 times the square root of 2 gives me the square root of 10. Underneath, square root of 2 times the square root of 2 is the square root of 2 squared, or just plain old ordinary 2. And so that works out to be the square root of 10 over 2. Now I can't break it down. I cannot reduce it in any way because 10 doesn't have any perfect squares in it. So I can't pull anything out of there. So this is as low as that will go. So again, looking at this, it's to the first. But if I had one more 2, I could make it a square. And if I could take the square root of 2, or the square root of 2 squared, then I would end up with 2. So we kind of got to break some stuff apart. In B, my radical is all together. In, I think it was 9.2, we talked about breaking these apart. And so I can break it apart and get the square root of 5 over the square root of 12x. So then I need to look at 12x and see what in the world do I have in 12x. So 9.2, where we have 2 squared times 3 times x. And what that ends up equaling is the square root of 5 all over, and I can pull out a 2. Notice that? So I can pull out a 2. Underneath my radical will be left a 3x. So the only piece that I need to multiply top and bottom by is the piece that's not a perfect square. So since 3x is not a perfect square, I need to multiply both top and bottom by a 3x. So if I do that, what do I have in the top? Well, I have 5 times 3 is 15. X comes along. And in the bottom, I still have my 2. But now I have 3 squared under my radical. And I have x squared under my radical. So when I'm all finished with it, I have the square root of 15x all over 2 times 3 times x, because they all come out. And my final answer is the square root of 15x all over 6x. I cannot cancel my x's because one is under the radical and one is not. So they do not cancel. All right? So a recap with this one is then I took this piece, broke it apart, found out what 12x was made of, found I had a square in there which I can pull out, leaving me a 3x, taking that 3x and duplicating it, and that's what I come up with. So then I multiplied it all, simplified the bottom, and came up with my answer. And so that is what happens to those. So questions with this one and what we have to do to end up taking care of it. Here's 2 that involve cubes. So let's see what we can do with those in order to make them work. So 7 is going to stay a 7. 32, though, 32 breaks down to 4 times 8. 8 breaks down to 2 times 2 times 2. And 4 breaks down to 2 times 2. We good there? That's basically what we've been doing before. So really, I have the cube root of 2 to the 5th y. So then what could I pull out of the bottom? I can pull out a 2, because 3 goes into 5 once. And it leaves underneath my radical a 2 squared and a y. We good with that? Yes? No? 3 went into 5, just like we did in 9-2. So 9-2 is in this whole section as well. So now what do I still need to make this a perfect cube to make it go away? So I have a 2 squared. So what would make that a perfect cube? So what would I still need? If it's a square, I would still need a 2 to the first power. Y is single here. So what would I need to make it a y cubed? A y, just a y? A y squared. Yep. Because again, you're trying to make these exponents under here equal to 3. Because if they're 3's, then I can pull them out. So on the top, I'm going to also do the same thing and multiply this 7 by 2y squared. So what am I left with? 7 times 2y squared in the top. The bottom, I have 3 times the cube root of 2 cubed when I put my 2's together, y cubed when I put my y's together. So then finally my answer is 7, the cube root of 2y squared, all over 3 times 2 times y. And then this will equal 7, the cube root of 2y squared, all over 6y. So if you stumbled and had troubles with 9.2, 9.2 is the basis of all of this stuff. So you want to be real careful with that. and make sure that you understand what we did in 9-2, because 9-2 is letting me break these things apart and finding out what's in them. Okay, questions with this one? This 3? Oh, up here?
Yeah. Why is that a 3?
It should have been a 2. Yep, thank you. Yeah, it should have been a 2, so this should really be a 4. I took the 3 instead of the 2. Thank you.
I was confused.
Yeah, you should be confused because it should have been a 2. Yep, because I pulled out a 2, I didn't pull out a 3. Yeah. So anytime that happens, please, 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 let me know that I do such things. So over here, in the next one, I get a 9. I break 16 apart. So 16 becomes 8 times 2, and 8 becomes 2 times 2 times 2. So cube root of 2 to the 4th power y. So in here, I can pull out a 2, and it leaves me with the cube root of 2y. So what would I need to make it a perfect cube in the bottom? So to get a perfect cube, I would need, this is to the first, and the y is to the first. So I need a 2 squared, and I need a y squared. So all I'm doing is forcing this bottom, just the radical piece, to disappear. So I'm left with 9. The cube root of 2 squared is 4. All over 2 times the cube root of 2 cubed and y cubed. So those will become 2 times 2 times y, times y. And so my final answer is 9, the cube root of 4y squared, all over 4y. Okay. So once again, we're pulling out what we can before we figure out what we need to multiply by. Now, could I just go through and not pull stuff out in the beginning? Yes, but it makes it hard to look at. The thing here, if you stopped at this point and said, I got to make perfect cubes, I would still need a 2 squared because it had to become a 6. If I were looking at this piece, it would have to become a 6. The y, I would need a y to the 2nd power still. So even if you didn't pull stuff out, you can still come up with what you need to put in it. Move it back up just so you get the bottom part there if you were missing that piece. Okay. Making sense? Hopefully. Okay, let's take a look at these two and see what we can come up with out of this stuff. Again, these are all the varieties that are going to show up in your work that you're going to do. So I've got the cube root of 10 over the cube root of 18. So if I look at 18, 18 is made up of 2 times 9, and 9 is made up of 3 times 3. Do I need to break the 10 apart in the top? Not necessarily, but sometimes it might help me. Pardon? Oh, that's out there. Okay, so then if I take this piece, I'm going to end up with the cube root of 10 all over the cube root of 3 squared times 2. So what would I still need to multiply it by? So what would I have to put in this radical to make the bottom a perfect cube? I need a 3 and 2 squared. Okay. So what am I going to be left with? In the top, notice I got a 2 squared here, but what do you notice about 10? 10 is really made up of 2 times 5. So if I have the cube root of 2 times 5 times the cube root of 3 times 2 squared. And that's going to be all over the cube root of 3 cubed, 2 cubed. I can put these 2's together and pull out a 2. So under my top radical, I'm going to have 2 and a 2 squared gives me a 2 cubed, a 5 and a 3. And in the bottom, I pull out my 3. I pull out my 2. But in the top, what can I still pull out? So sometimes you get some combinations that are going to give you more things in the top you can pull out. So in the top, I can pull out a 2, leaving me with the cube root of 15. In the bottom, I have 6, but 2 and 6 will cancel. So if you put an answer into Hawks and it says it's not reduced, that's more than likely what's happened, is you haven't pulled out everything in the top that you can pull out. So my final answer on this whole thing is the cube root of 15 all over 3. So if you ever run across when you're putting stuff in there and it says not reduced, that's more than likely what's happened, is your top piece hasn't reduced and you haven't come up with what you need for that. Okay, so that's the piece that we need to watch and see what you can do with with those. So okay, does that make sense? Because again, I broke my 10 apart so that I could see what combines up here. So sometimes you can do that and you can end up pulling some stuff out. The previous ones we had, we didn't have anything to pull out of them. And so there wasn't something there to work with. So what about this one? What do you guys think I should do? Have the next one here. Square root of 14 over the square root of 7. Since it's square roots, I'm looking for 2 things. So I got to have everything be in squares in the bottom in order to remove it. But 7, does 7 break apart? 7's just 7. So I'm going to need the square root of 7 here and the square root of 7 there. So what does that leave me with? In the top, 14 is 2 times 7 and the square root of 7. And in the bottom, I have 7 squared. I can put my 7's together in the top and have 2 times 7 squared over 7 in the bottom, because that's going to end up reducing there. But in the top, I can pull out a 7, leaving a 2 under the radical, 7 in the denominator. So then what happens is the 7's both cancel. So my answer is simply the square root of 2. So I get the square root of 2 out of that one. So that's the stuff that's happening with those. So you want to be careful and make sure that you have your values in there and that you're breaking stuff apart even in the top. So stuff combines in there in some cases. Okay. Questions with this one? Again, getting those square roots of 7's and coming up with those. Okay. All right. So now moving on to rationalizing denominators that contain a sum or a difference involving square roots. So if the denominator fraction contains a sum or a difference involving a square root, we only do these with square roots. No cube roots involved with these. Okay, so we're not going to rationalize denominators with cube roots. So to rationalize the denominator by multiplying both the numerator and the denominator by the conjugate of the denominator. And what that means is way back when, in basic algebra, in factoring, or before factoring, actually in polynomials, if we took something and we multiplied it by its opposite piece, such as a minus b times a plus b, and we FOILed that, what happened? Well, we took a times a, and we end up with a squared. We took a times a plus b as a positive ab. B, negative b times a is a negative ab. And finally, b times a negative b times a positive b is a negative b squared. But when we look back at this and we combine stuff, what happened? They canceled out, right? And so because they canceled out, we were simply left with a squared minus b squared. When we rationalize denominators, that's the thing we want to have happen. So we want to have this piece disappear in here. We want it to go away, so we don't have anything to do with it. So we want to make sure it goes away, and so that we don't end up having middle pieces, because in those middles, we're going to end up with radicals in here, and we don't want them in there. We want them gone. So we're going to do this kind of thing. So we're going to take these and end up multiplying those out. So in continuation, if the denominator is the form of a plus b, we're going to multiply it by a minus b. So basically, if this is a plus, the opposite one's going to be a negative or a subtraction. If it's a subtraction, the opposite's going to be a plus. And so then the new denominator will be the difference of the two, and therefore contain no radical terms. So we're going to get rid of all those radical pieces that are in there with those. So let's take a look at some here. So what would be the binomial I would multiply by this thing? Well, it's a minus. This is a and this is b. So I would take the bottom and multiply it by 4 plus the square root of 2. Because again, getting that opposite piece in there is going to make my middle stuff go away. So again, whatever I did to the bottom, I also need to do to the top. So I'm going to put it up there, and I'm going to multiply it by it, and we're going to see what happens. So if I multiply it through, 2 times 4 is 8. 2 times the 1 in front of the square root of 2. This is the stuff that we learned in the first sections, and that would have been in 9.4b, I think was where we did multiplication, and we FOILed stuff. And so that's the key from there. Then in the bottom, 4 times 4 is 16. If I multiply the middle, just to show you what happens, 4 times a positive square root of 2 is plus 4, the square root of 2. Negative square root of 2 times 4 is a negative 4, the square root of 2. And finally, negative square root of 2 times a positive square root of 2 is a negative 2. And we had that the other day too, because whenever we multiplied a square root by a square root, the root disappeared, and you just had the radicand underneath. So what happens here is, of course, those middles disappear. So my answer is 8 plus 2, the square root of 2, all over. Now, because these disappear, 16 minus 2 are like terms. So 16 minus 2 is 14. So I get that for my answer. But it's not reduced, because we can pull a 2 out. And the 2 and the 14 will cancel. So we're really left with 4 plus the square root of 2 all over 7 would be my final answer. Okay? So when your radicals disappear in the denominator, you're going to end up with a solid number. Usually there isn't anything left unless there's a letter involved. So if you've got an X in there or a Y or some variable, then you'll have a variable with it. But in most cases, you could end up taking those and subtracting them to come up with what your answer is. Okay? Questions with this one? And again, it was a negative, so I did and worked with a positive in here. So I switched signs, and that again made it disappear for me. Okay, so how about this one? Chance to put it on your paper. So since it's a plus sign in the center, I'm going to do 6 minus the square root of 5. And again, whatever I do to the bottom, I do to the top. So I end up getting that piece together. So then what happens? Then I got to take 31 times 6. 6 times 1 is 6. 6 times 3 is 18. 186. 31 times a negative square root of 5. Negative 31 square root of 5. And in the bottom, 6 times 6 is 36. Do I need to go through and do all the middles? do you guys think? I need to go through and do this piece and that piece. They're going to go away. So basically, 6 times 6 is 36. The square root of 5 times the negative square root of 5 is a negative 5. So that leaves me with 186 minus 31, the square root of 5, all over 36 minus 5 is 31. And I multiplied by 31. Sometimes you don't know till you go through and do it. That it needs to factor right back out again. So 31s cancel. So my answer is 6 minus the square root of 5, since they cancel. So maybe hold off on doing this multiplication on the top until you get your bottom. If you do that, then you don't have to go back and factor it back out again. So leave this top part unmultiplied and then go back through and see if you have to multiply it to get your answer. Right? Questions with this one? Anything with that one? These, again, is taking your skills you had from Monday and applying them to stuff in this section. So, okay, can I flip it? Okay, let's see what we got back here. 1 over the square root of 7 minus the square root of 2. So its conjugate is going to be square root of 7 plus the square root of 2. Top and bottom. Lots of foiling. 1 and distribution. So I get square root of 7 plus the square root of 2. Bottom, square root of 7 times square root of 7 is 7. Negative square root of 2 and a negative square root of 2 is a minus 2. So my final answer is the square root of 7 plus the square root of 2 all over 5. These aren't really hard. It's just that you've got to remember your rules that apply to square roots. And that when you got a square root times a square root, the square roots disappear as long as your radicands are the same within those. Okay? See what you guys get on that one. We'll work the next one. See what happens to it. Again, when you foil the bottom, all you need to do is the F part, the first term, and the L part, because your middles are going to be forced to go away. Okay, so the forcing of those to go away isn't going to be there anymore. So then, when I multiply top and bottom, I get 6 minus 6, the square root of x, all over 1 minus x. Can't combine that because I have no clue what x is with those. Okay, so a couple more in here. Let's see what happens with these guys. This one's a tad different because you got to really foil the top because you got a binomial times a binomial. So square root of x plus the square root of y. So the top gets foiled too. This one kind of threw you a little curve in there, because if you didn't FOIL the top and you left it alone, your bottom, x minus y, matches x minus y. So the two of those will cancel out. And so you're only left with the square root of x plus the square root of y. What was what? This is, yep. This kind of leads you to think, oh, I got to write out the whole thing in there. But once you look at this piece and you go back to look at your original problem, you'll notice this matches that. And since this is a binomial in the top part and this is a binomial, we can just cancel these two binomials out altogether. And so that's what wipes that piece out. So you end up with square root of x plus the square root of y. Again, what Hawks would tell you with this one is that you didn't simplify it. So if you type this in, it would come back and say it's not simplified. So if you ever see that not simplified, that's going to mean that somewhere in your problem there's something to cancel. So there's somewhere that something pops out of here that cancels. So that's your clue if it does end up telling you that. Okay, so you want to be careful with that part. This one over here, -1 over the square root of 6 minus the square root of 7, its conjugate is going to be square root of 6 plus the square root of 7, which we know. When I distribute, I get a negative square root of 6, a negative square root of 7. Square root of 6 times square root of 6 is 6. Negative square root of 7 times a positive square root of 7 is a negative 7. So I have a negative square root of 6 minus the square root of 7 all over a -1. But can I leave it like that? Hawks is going to scream at you because I can't leave a negative in the denominator, and 1 isn't going to give me anything anyway if I left it in the denominator. So what this means is I need to change every sign up here. So I'm going to have the square root of 6 plus the square root of 7 over 1, but now I don't need the 1 anymore. So the 1 doesn't need to be there. So I can get rid of that 1 and not have it in there. So that's what happens with this one. Okay, are we good, you think? Okay, as long as we are getting that stuff down. Then the last piece is putting these things in your graphing calculator, and I don't think anywhere in your homework it asks you to do this, but it's kind of a good review. So if I were to put this in my graphing calculator, I would simply put it in as I see it. So it would go in as 3 plus 2 times the square root of 5, hitting enter, and you would end up with, of course, what your answer happens to be. And it will always say, usually round to 4 decimal places. So we would round it off and get our 4 decimal places. So it's just kind of a review of saying, how would I put that on my graphing calculator if I had to come up with an exact answer of what that thing was worth. Now, not exact, but a decimal answer of what it was worth. The exact answers are what we've been doing with those. Then if you have parenthesis ones, same process. Square root of 2 plus 5 inside of parentheses times the square root of 2 minus 5, and you will end up with what your answer would be for those. So if you had one of those in the denominator of your problem, notice it's a conjugate, opposite sign in the center, a plus here and a minus there. And so it's kind of the conjugate stuff and coming up with that -23 that you would have ended up coming up with anyway, because you would have had 2 squared give you 2 if you did it by hand, plus or minus 25, which still is a -23. Actually, I think doing it by hand is faster than doing it on your calculator, because you know the square root of 2 and square root of 2 disappears. The square root does. 5 times 5 is 25, and you're right there. I think it would take me longer to put on my calculator in this case because of stuff that ends up disappearing in there. If it's underneath, like we had the radicals underneath and coming up with just what that solution would be, again, when you do your calculator ones, though, you want to put your 3 divided by, but don't forget parentheses here. Very important that on your calculator you put parentheses, because if you don't, your calculator will say 3 divided by the square root of 6. It'll get that answer, then it would subtract the square root of 2. So you need parentheses here because it's grouping and you need the answer to that denominator before you divide it into the top. value. So be careful with those types. Okay, are we good, you think? Okay, do we need to practice anymore? Got lots of practice problems in here. If we did have to do some, these are here. If you go back and you watch this taping of this thing, they're all here. I'm going to again show the pages where they are worked out, just so that if you're looking at the video, you can stop it and see how those problems end up being worked out in there. And so again, it just kind of finishes up everything in the video. Again, for in class, don't worry about writing them down, because we've basically have worked with these different varieties. This one's got a lot of A's and B's in it, and it's got a lot of combination stuff. So this was number 6. So you had to come up with values in the bottom, but if you just walk yourself through it, it's not that hard to do in coming up with those. And it was a cube with those. Here's 7 and 8 worked out, and so that they're there too. And 9, 10, and 11. Again, they gave you lots of practice ones in here for these. And then finally, 12. 12 had a lot of different stuff into it and a lot of things to break down in it. So you just got to be real careful with those and coming up with them. And then that's just the answer sheet for those. Okay, so we good, you think, with that part? Hopefully. So might as well move on to 9.5. 9.5 is equations with radicals. Equations, the definition of those, of course, is that we have an equals. So there is an equals involved with those. So we're going to have a equals in there, and so then we got these radicals that are involved, but we're going to come up with ways in which we can take care of those. So solving equations containing one or more radical expressions. So in working with those, you're going to isolate the radicals on one side of the equation, meaning that if you had the square root of 2 plus 4 equals 7, we are going to minus 4 from both sides to get that square root of 2 all by itself. So then what I would be left with is the square root of 2 is equal to 3. And that's, of course, not true, but I just plugged some stuff in here, and we ended up coming up with that. So probably I should have made this 2 an x instead. Then we could have something we could solve. But we're going to get the radical by itself. Then raise both sides of the equation to a power corresponding to the index. So if I have a square root, I'm going to square each side. If I have a cube root, I'm going to cube each side. So I'm going to cube them. So instead of only taking a square root, it'll be a cube root with those. And then if the equation still contains a radical, repeat steps 1 and 2. These are not in your homework at all. So we are not doing that variety. So that piece will not be part of any problem that you'll run across within your homework and to do those. Okay? So let's see what we can come up with here. And then finally, we need to solve the equation after all radicals have been eliminated. So we're going to take it and we would end up solving it. So if I was back to my square of x and I got it to equal 3, I would square each side like it told me, which is going to give me x is equal to 9. So I would find out that 9 would be my answer. But then number 5, check it. Be sure you check these, because sometimes the answer you come up with doesn't work. It comes out as an answer, and it's a legitimate answer to what you're working on, but when you take the square root or you do some different things with it, it doesn't work. So you want to make sure that you eliminate those solutions. And some are going to have no solutions because nothing will work and nothing will make those things work. So we got to be aware of that. So there are some no solutions that will pop up in here. So make sure that you watch those. So let's take a look at one. This is one that we happen to have in here. And so our rules say we got to get the rational or the radical piece all by itself. So we got to get this alone. Is it alone? Yeah, it has nobody else added to it or subtracted from it. So it's by itself, so that's good. So that piece is taken care of. The second step is because the index is 2, that tells me I'm going to square this side and I'm going to square that side. So if I take each of those and square them, what do I end up with? Well, this side, and again, you do not need to write this out as you do these. I just wanted to show you that what you end up with is a square root and a square root, and we know that what's underneath there is what we end up with. That's the same process as we've been doing, the square root of 7 times the square root of 7, we drop the radical. And so that's what happens in here. This radical goes away, but this side I need to square. So 7 squared becomes 49. We good? Okay. Oh, so far, so good. Then to get x, and I got to solve this, so I can minus 13 from both sides. So I end up with x squared is equal to 9 minus 3 is 6. 4 minus 1 is 36. So, and because this is squared over here, I can move the 36 over. So I can take x squared minus 36 is equal to 0. Factor it. Negative 36, I get a negative 6 and a plus 6 equals 0. So x minus 6 equals 0 and x plus 6 equals 0. So I find x is equal to 6 and x is equal to a negative 6. So that's what I would have to do to these in order to solve them. So I've got the solving done, but now the check. And you can use your calculators to check this if you want. So under here, I'm going to take 6 and square it. Plus 13, is that going to equal 7? 6 squared is 36. 36 plus 13 is 49. And it does equal 7. So I can use x equals 6. Or negative 6. Negative 6 squared is 36. And we just proved this up above. So the square root of 49 does equal 7. So we are good to go. Okay. So both answers I can put into my answer for this one. So both positive 6 and a negative 6 will end up working. Okay. Again, it's that process of going through and using some of the rules and techniques that we've had. Okay. Let's look at this next one. Not that one. So this one, again, is my radical by itself. So first off, ask that question and get it copied down on your paper here. So my radical doesn't have anything added to it out here, and we'll get some in a little bit that do. So I can square each side. So when I square this side, the radical disappears. But when I square this side, I need to FOIL it. Don't just square the 1 and square the y. Not the right way to do that. 1 times 1 is 1. Y and another y is 2y. And a y times a y is a y squared. Get it set equal to 0. So I am going to, well, I don't know, which way do I want to move stuff? Doesn't make really a difference in which way. So we'll move the 11 over. We'll move the 10y over. And we will move the y squared over, making a negative y squared. So 0, everything cancels that side, equals 1 and 11 is 12. 2y and 10y is 12y. Y squareds are gone. Move the 12 back over. Divide by 12 to get y all alone. And I find out that y is equal to a negative 1. So far, so good? So all your algebra skills, clear back from basic algebra, are all kind of in these problems because you've got squaring you're doing, you're multiplying stuff, you're solving for y, you're taking your answer, substitution, because square root of negative 1, 10 times 1 plus 11, is that equal 1 plus negative 1? Well, 1 is 0. So I'm going to find out if I get negative 1 times 1 positive 10. And sure enough, I get the square root of 0. And the square root of 0 is 0. So therefore, I know that I have my solution. Good or not good? Okay. Why don't you guys try this one? First one, we got to move something over. So get that one written on your paper, and I'll give you some time to work on it. And we'll see if we can get a correct answer to it. So the only difference between this one and the previous ones was that you have a 3 here, which needs to move over. And so that becomes your equation. So now go through it, square it, just like the last one. And foiling and solving, you'll have to factor this one more than likely. Oh, anybody getting answers? Getting close, maybe. This one's probably one of the longest ones that you'll probably run across because it has basically every piece of stuff in it that you could possibly have. All right. Get an answer? Should have two answers at the when you get done doing the first part. Anybody got them? What they were? You can say it. I mean, 4 and a negative 1/4. Yes. So if you did this and you ended up with those, yeah, you're on the right track. Because over here, when you take and you square each side, you FOIL or get your stuff, move it over, factor, you get a negative 4, 1/4, and a positive 4. But do they both work? So if you go back and you check it, this 1/4 comes out to be some kind of strange stuff going on here. I get 7/2 when I take 3 from 52, I get 49/4. Turn the 3 into halves after I take the square root of this, and I get 7/2 plus 6/2 does not equal a half. So I know that one doesn't work. But when you check 4, 3 times 4 is 12. 12 plus 13 is 25. Square root of 25 is 5. 5 plus 3 is 8. And over here, sure enough, 2 times 4 is 8. So really, the only solution that we can end up using with this one is x equals 4. So again, take your time with these and make sure that you end up getting them to work out. So hopefully you got some of that stuff in your notes and you worked on this one. If you didn't work on it, I can't help you there because you're supposed to definitely go through and see what you can do as far as working through it. But again, take your time with it, and they do work. But again, it's all of your algebra skills that you've possibly learned. So let's take a break. We'll shut this down for 5 minutes and come back and we'll see what we can do with this thing. So yeah, move around. my microphone back on, I think. Yep. Okay. Why do I have watch, this one on here? Why do I have watch at the top of it? Yeah, that's right. Exactly true. It's a negative. It's equal to a negative. Can I have something that is a square root equal to a negative number? I think we learned that in 9.1, that we can't have that because I can never get a negative out of a square root. Okay, so this one is basically no solution. But let's say you didn't remember that. So you say, oh, you're just tootling along through these and you hit this problem and you're on that goal of saying I'm going to square each side. So you go through and you square each side. So I square this and I square that. So I get x plus 1 is equal to negative 3 squared is 9 minus 1. So we could say x is equal to 8. Like, wow, okay, I've got an answer. But if you follow your tradition with this, and if you can't remember that you can't get a negative, if you follow what we've been doing, I need to check it. So if I check it, I get the square root of 8 plus 1 is equal to a negative 3. 8 plus 1 is 9, but the square root of 9 is a positive 3, not a negative 3. So even if you can't remember that you can never have a square root equal to a negative, if you don't remember that and you go through and you do your whole process and you check it, you're still going to end up with no solution. Okay, so so you want to just remember that. You just go through your process and see what happens with that and check it. Do you think we need to do this one? Or are you guys okay? What do you think? I think we probably should do it. So work on it. See what you guys get. This one's not as long and involved as that one that I had to do by yourselves before. So this one's a little shorter because it doesn't end up with something we've got to FOIL on the opposite side. So it does come out a little bit easier. Again, check these. Don't just say, oh, I'm good, I'm going to just plug in my answers, because it does catch up with you. And if you don't check them and you get quite a few of them wrong in your certify, you're going to end up losing your points in there because you're typing in something that doesn't work. So check those. If you need, use your calculator. We talked about entering these things in your calculator. So I would put my radical, parenthesis, 3 plus 6 times 1, close it with a parenthesis, and see if it equals 3. And if it equals 3, you're good to go. Okay? So you can do your check on your calculator, and that helps you out with those. So, so do check them so that you make sure that you end up with what you're supposed to. Everybody get 1 on that one? Yeah. Most of your problems are probably more like this than they are of the long ones that you happen to have. This one is another long one. I'm just going to leave it here. I will go back in your notes and I will work it out for you. But again, we won't do it right at this point. So it's in there for you to work with. So we'll skip that one, but we didn't do that other one. So equations with radicals, note that it's possible that after checking an answer, you may have none of the answers as solutions. So you could get up with a no solution in there. So that's just kind of a reminder that no solutions do pop out with those. If you run across one that has 2 radicals on each side, no big issue, because to remove the radicals, what did we do? We squared each side. So when I square each side, what's going to happen now? Square a square root, I get what's underneath it, so the radicand comes out. Square another square root, same thing happens here. So if you've got radicals on both sides, just square them and away you go. So I'm going to move my x over. Add 2. And I'm going to find 4 plus 2 is 6. 3 minus 1 is 2x. Divide by 2. So I find x is equal to 3. Is it true? So 3 plus 4, is that equal to 3 times 3 minus 2? 3 plus 4 is square root of 7. 3 times 3 is 9. 9 minus 2 is also square root of 7. So we could type it in as a solution. So it can be your solution to that equation. So it does work. So if you want, you can stick it in there and make sure that it works. Cubes, on the other hand, let's get this out of there. The only difference between a cube root and a square root is that instead of squaring, we're going to cube whatever we happen to have. There will never be a variable on this other side. So keep that in mind that there's no variable there. So I still got to get it alone. So I'm going to minus 1. Cube root of 2x plus 1 is equal to 3 minus 1 is 2. So the only difference is the index is cubed. So I'm going to cube this side, and I'm going to cube that side. If I cube a radical that's already cubed, or the cube root of it, I'm going to just drop the radical. But on the right-hand side, I need to cube the 2. So 2 times 2 times 2 is actually 8 minus 1. 8 minus 1 is 7. Divide by 2. Get x equals 7 halves. So I check on this one, plugging it in here. 2 times 7 halves plus 1 on the outside, does it equal 3? These 2's will cancel inside, so it made it nice. 7 plus 1 is 8, plus 1 on the outside. Cube root of 8 is 2. 2 plus 1 is 3. So it does work. So 7 halves would be my solution. So you want to plug it in, and you want to go through and come up with what your solutions happen to be with those. So cube roots, just take the cube of them and then see what happens. Then there's some practice problems in here with these. And so again, we've got those. 1 was crossed off because we don't have radicals on both sides. There's no radicals on each side in your homework, so that one was crossed off. And so then here's the answers to each of those. And again, just showing those up there to make sure that we have what's there. And number 3's answer. And again, if you're watching it on video, you can just stop them and work your problems out. And then finally, number 4, which is there too. And so number 4 is a no solution because of that negative out here. But if you don't remember it, you can still work it through. So it'll still come out and it won't work. And then there's the answers to those practice problems. So questions on doing this stuff? Anything with it? You need to practice stuff, okay? 9 is kind of building, and so 9's got a lot of stuff in it. So if you're behind on homework at all and don't have any of your sections done, this stuff's getting tougher, and it's going to keep getting harder. So you have to stay on top of 9. It doesn't pull together if you don't have certain things done. So make sure if you're behind, get caught up so that you don't end up missing out on what you do need to do with those. Let me stop this thing.